Hello, my name is Lindsay, and I'm an early childhood education student at MTSU. Today I'll be demonstrating how to teach a third grade math standard using manipulatives. The standard I'll be demonstrating is 3.nf.a.3, explain equivalence of fractions and compare fractions by reasoning about their size. Specifically substandard B, recognize and generate simple equivalent fractions and explain why the fractions are equivalent using a visual fraction model. The manipulative that I will be using is a set of standard pattern blocks. I will use yellow hexagon blocks, blue diamond blocks, red trapezoid blocks, and green triangle blocks. Start by explaining to students that you are using fractions to describe parts of a whole. We can use the pattern blocks to represent one whole. If a blue block is one whole, then two green blocks, or 2 over 2, is also one whole because they take up the same space. If a red block is one whole, then 3 green blocks, or 3/3, is also one whole. If a yellow block is one whole, then 2 red blocks, or 2 over 2, is also one whole. If a yellow block is one whole, then 3 blue blocks, or 3 over 3, is also one whole. And if a yellow block is one whole, then 6 green blocks, or 6 over 6, is also one whole. You can see that beside each other, these are all the same. This provides students with a concrete visual model. You can also show students that fractions that do not look the same numerically are actually equivalent. They now know that 3 blue blocks are equivalent to 1 yellow block. If 1 yellow block is the whole, and only 1 blue block is there, that's 1/3 of the whole. You can then help students see what other blocks can achieve this and look the same. They now know that 2 green blocks are equivalent to 1 blue block, and 6 green blocks are equivalent to 1 yellow block. If 1 yellow block is the whole, and only 2 green blocks are there, that's 2/6 of the whole. This can help students see that 1/3 and 2/6 are equivalent. You can show students that 2/3 is equivalent to 4/6 in the same way. If 1 yellow block is the whole and only 2 blue blocks are there, that's 2/3 of the whole. If 1 yellow block is the whole and only 4 green blocks are there, that's 4/6 of the whole. Those blocks take up the same amount of space on the yellow block, so the fractions are equivalent. You can also show that 1/2 is equivalent to 3/6. 1 red block takes up the same amount of space as 3 green blocks. Students now know that 2 red blocks are equivalent to 1 yellow block. If 1 yellow block is the whole, and only 1 red block is there, that's 1/2 of the whole. If 1 yellow block is the whole, and only 3 green blocks are there, that's 3/6 of the whole. Students can see that these take up the same amount of space, so the fractions are equivalent. Once students have sufficiently practiced representing and comparing fractions in this way, you can present them with a word problem. Here is an example. Carissa and Layla are sharing a pizza with 6 slices. Carissa eats half of the pizza. Layla eats 3/6 of the pizza. Do they eat the same amount? Students should recognize that 6 slices, or 6 green blocks, also represent 1 yellow block, which they can use as their whole. Since Carissa ate half of the pizza, she ate 1 out of 2 parts. Help students think about what blocks they can use to show the same amount in 2 parts. They should recognize that they can accomplish this with red blocks. Carissa ate 1 out of 2 parts, so we can separate that 1 part and put it to the side. Since Layla ate 3/6 of the pizza, she ate 3 out of 6 parts. Again, help students think about what blocks they can use to show 6 parts. They should recognize that they can accomplish this with green blocks. Layla ate 3 out of 6 parts, so we can separate those 3 parts and set them to the side as well. Since they learned in their previous exploration that 3 green blocks are equivalent to 1 red block, they should be able to see that these amounts are equivalent, so the girls did eat the same amount. This is how you can use pattern blocks to teach this standard. Ideally, each student would have their own set of blocks to work with. Students should be allowed to explore the relationships between these blocks before they are explicitly taught them. This hands-on approach will enhance their learning.